Hello, you're welcome to Dynamic Teachers Hub, a platform designed to transform your mind for a productive living. Just in case you have not subscribed, please do well to subscribe, like, share, and then turn on your notification bell so that you can receive more of these kind of teachings, this kind of calculations, and this kind of technical drawings from time to time. Thank you, and God bless you. Today, we are going straight to calculations. We're going to be solving several calculations on the design of shaft. Now, in the design of shaft has to do with the determining of the various diameters of the shaft. We have what we call solid shaft and we have what we call hollow shaft. In these calculations I'm going to be solving, we'll be solving for solid shaft. Just follow me as I teach you how to solve for the solid shaft of a machine. Alright, welcome to class. Today I'll be teaching you how to design a shaft by determining the diameter of either a solid shaft or an hollow shaft. Now, we have two questions here. This is the first question. This is the second question. Now, the first question here says that a solid shaft made of mild steel is required to transmit 100 kilowatts at 300 revolutions per minute. The supported length of the shaft is 3 meters. It carries two pulleys, each weighing 1.5 kilonewton, supported at a distance of 1 meter from the ends of the shaft respectively. Assuming a safe value of stress 60 megapascal, determine the diameter of this shaft and show your sketches neatly. Now this is the question and here is the solution. You can obviously see we are giving power here, power to be 100 kilowatts then, and you know that kilo means 1,000, so you multiply the 100 by 1,000 and then you have your 100,000 watts. And then if we are giving number of revolutions to be 300 revolutions per minute, and then we are giving tension T1 and T2 to be 1.5 kilonewton. You convert that kilonewton to newton by multiplying it with 1,000, and if you do that, you're going to have 1,005 newton, and then the stress that we are giving is 60 megapascal, which if you convert it, it will be 60 times 10 raised to the power 6 newton meter square. Now the diameter of the shaft is what we are to look for. When you are asked to design a shaft, what you first of all do is to find the diameter of the shaft. And now look at the formula. The general formula for finding the diameter of a solid shaft is this, and this tensional energy was given to us. The formula is the square root of moment square times tensional square. And of course, you recall that torque is equals to 60 times power divided by 2 pi n, and this n is the number of revolutions that we are given. If you impute every value, of course, you are going to have this number as 3,182 newton meter, and approximately you are going to have 3,183 newton meter. Then after that, remember that you were told, look at the question, that the 1 meter from each of the ends of the shaft respectively, and at the same time the supported length of the shaft is 3 meters. The meaning of supported length is the distance between the two middle torsional forces. And look at the support here, 1 meter from the end, and then 1 meter from the head, and at the middle you now write it 3 meter. And recall that according to this one, now is now a moment question, moment resolution, and according to the law of moments, that upward forces is equal to downward forces, and if you impute that, you will find out that RA plus RB equals 1,005 plus 1,005, which are the two tensional forces that are acting upon the beam. And if you resolve that, you're going to have RA plus RB equals to 3,000 newton. And the next law of moment, which is clockwise moment, is equal to anti-clockwise moment. And you decide where to take your moment from, either from point A or point B. If it is from point A, you are going to say the sum of the moment at point A is equal to 0. and then you are going to find the moment of this tension 1. The remember that moment is force times distance. This force that is distance is used in departing from this position that is going to, and if you are going to do this one, it's going to be this force times this distance. That's distance between here to here is 4 meter. Distance between here to here is 1 meter, and the distance from this place to here is about that's everything is about 5 meter. So coming here now, you're going to have to be the first one, which is the first T one, is going to be 1005 times the 1 meter distance plus 1005 times the 4 meter distance equals to the other one is the anti-clockwise moment. Anti-clockwise moment. Look at this place now. Look at this place. You can quickly draw this in your wall clock sign to know which one is clockwise and which one is anti-clockwise. This one coming this way is clockwise, and this one going against the movement of the wall clock is anti-clockwise. And by that you can now know that the anti-clockwise will be the RB times the entire distance he used in getting to this point A that we took our moment from. Having done that, you can evaluate easily, and of course, you're going to have your ROB to be 1005. If you have your ROB to be 1005, you recall that we first said that ROA plus ROB is equal to 3000 Newton. That was our equation 1. And then you now make ROA subject of the formula, and you repeat the value of ROB, and of course, you're going to have this. When the moments are now the same, that is when you can now say, okay, moment of the entire system is equal to 1005 times 1. This one from this point to this point, and the distance there is 1 meter. And that's why we used 1 meter to easily multiply this to have this. But ensure that you resolve these reactions to verify your answers first before you cannot pick any of the reaction support, to carry out your calculations. And then of course our TE, which this is the formula, you put in the value, which is the moment we just got, and the torque we have resolved for, and you do all of that. After resolving it, of course, you are going to have this answer. You are going to have this answer. I recall that the formula for finding the diameter of a solid shaft, which was given to us initially, is still here. And when you bring it in, you put in every value, and you ensure that this 60, the stress which was given to us as 60 megapascal, you will now convert it to Newton per millimeter square, and then you now pick the 60 to evaluate your calculations. And when you do that, you are going to have this. And when you now get to this, you multiply by 1000 before finding the cube root. Why? Because this answer is in meter. You have to convert it to millimeter by multiplying it with 1000. And if you multiply with 1000, you are going to have 66.8 millimeter. When designing for the diameter of shaft, it is important to take the approximate whole number, either 10, 20, 40, 50, 60, 70, just like that. But in this case, since this one is 66, you take the next whole number. You take the next whole number that you can take, and the next whole number is 70 millimeter, which is the diameter of the shaft to this first question that we have just resolved. This is how to solve this question, and when you do that, you will be very glad that you now know. And what you need to know is that ensure that these formulas you master them, and you can go through all this calculation again to know the process again and again. And with that you will be able to get the diameter of a solid shaft effectively. Thank you, and God bless you. Bye.